Hello, welcome again to our lecture series on certificate course on geographic information systems. My name is Sheyi Fabiyi. I'm giving you this lecture on GIS databases. GIS, as we have described, is a system for capturing, for analyzing, for modeling, for displaying geographic reference data to solve complex health-related problems. Today, we are looking at GIS databases, and GIS data is made up of two data types, which is known as spatial data or geometric data, and non-spatial data or spatial data, or we call it attribute data. These are the two major types of data that are used in geographic information systems. And spatial data relate to maps, relate to cartograms, relate to diagrams, relate to cartography, while the attribute data relate to the database, relate to information that describe, that give further description of the geometric data set. So a GIS comprises of spatial data and the attribute data. As we said in the first lecture, lecture 1, there are 5 components of a GIS, which include the software. Well, we introduce the software as proprietary or commercially available software, where we have the Esri GIS software like ArcGIS, and we have MapInfo and all sorts of other types of commercially available GIS software. And we also have open source GIS software like QGIS, SVG, and other types of open source. And also, we said earlier on that software is critical and form usually the major investment in setting up a GIS laboratory. The second one is the people, that is the experts that will introduce the procedure or the techniques to use GIS to manipulate GIS databases and datasets using the GIS software to achieve solving a problem on the Earth surface. We also have procedure, which are the techniques and procedure or method conventionally used to solve the problems, and then we are trying to upscale the procedure for solving those problems in the GIS environment. We have the hardware, which is talking about these computer systems and also some of the peripherals, like the printer, the plotter, the even GPS, all this one. Now, what is central to the GIS is the data. Data is critical, it is central, and it must be geographically referenced. If it's not geographically referenced, if it's not related to the part of the Earth surface, then it is not useful in the GIS. So when we look at the subsystems of a GIS, we have the input, we have the analytical, we have the output. Just as we have in the typical computer systems, we have the input systems, we have the output systems, and then we have the central processing unit. Under the central processing unit, data is critical. We have the data input processing, we have the data storage and retrieval, we have data manipulation and analysis, we have the data display and product generator. All these ones are the critical components of a GIS systems that makes it very germane to any GIS systems. So same thing in an input storage and manipulation system, data is very key and critical. So how do we get this data? Under the mapping function of a GIS is still going to use data that we collect in form of point, line, and polygon, as we said in our last lecture, or in form of a raster, as we said in the other lecture. GIS and other subsystems we use. GIS actually harvest data from other subsystems. We have remote sensing systems, cartography systems, photogrammetry and remote sensing, computer-aided design, database management systems. All these ones generate data to GIS and they are used for the purpose of achieving the what we need. Now we have the geographic data, which we call the spatial data or geometric data. We have their data can be represented in raster format or can be represented as vector format. The raster format is in form of cells or picture element, or what we have like is represented as digital numbers. Digital numbers or gray values or pixel value are the codes used to represent features on the earth surface. For instance, this is a river system. River system in the vector environment will be represented like as a form of series of arcs and nodes or point and polygon as we have here. But in the raster environment, it will be represented as series of cells which have different uh, color. Color are used to represent the river system. So we know that when we are representing, and this is the river, this same river channel is represented in the vector like this and like this, but it's represented like river like this in the vector in the raster environment. So there are different type of representation. If you are using vector-based GIS software, the river channel will be represented as this. If you are using a raster GIS software, the river system will be represented like this. And we know that you can convert from raster to vector, or you can convert from vector to raster. But anytime you are changing from vector to raster, you are losing data or you are gaining data. There are so many errors that are involved. But it depends on whether that error is it will affect the quality of your analysis. So what we have in GI, what we call a GIS database system. It's a system to achieve and organize and store a large number of dynamic associated data, facilitate for multi-user accessing to computer hardware, software, and data. That it is a computer system with database technology. What we are saying here is that a typical GIS database allows several users to have access to the GIS database, and it can be through an enterprise systems. So what are the types of database you can have? You can have a flat file or spreadsheet, just as we have in Excel, or you can have hierarchical structure that store data in more than one type of record, that they are described as parent-child relationship or one-to-many. We also have relational database system that connect different files and tables through a relational pointer. And then we also have object-oriented database system that allow data to be stored in object linkages and object embedded system. So we have a different data format when you are in vector environment or when you are in raster environment. If you are in vector environment, you can save this as DWG. That is what AutoCAD used to save data. You can have DLG, that is the database of United States Geological Survey. You can have GML or XML, that geographic geography markup language. You can have GeoJSON, which is the database of the open source GIS software of QGIS. You can have GeoMedia. You can have Microsoft GeoMedia is what Microsoft Access is using. We have different types of database in the vector environment. In the raster environment, we have DEAL, we have ECW, we have GeoTIFF, we have TIFF, we have S3 grid, we have MRSID, and so on and so forth. So these are the types of data format you can save your data on. The open source GIS software also have their different approach to save data. So what is critical in databases is what we call data dictionary or metadata. Data dictionary is the document that describe or contain information about the data in the database. For instance, it can contain the information about the date it was acquired, the person that acquired, the accuracy level, the input data source, like whether it's an image, that you got the data from an image or from sensor data or from other. And so it gives you the information about the data. So metadata refers to data about the data. You usually call it data dictionary, meta, or a description of relevant details such as date of creation, custodian, the original or source of the data, the currency of the data status, how to access the data, data quality, and if there's cost to whoever is going to have access to the data. So we can implement these GIS databases in different approaches. Number one is that we can implement it in a workstation, which is a standalone system that contain all the database we have in one place, in one system, as a standalone. So you have all the database you have. The other one is enterprise-wide GIS, in which case the GIS series of PCs with the computer are connected by a network and data resources, and they can have access to different data sets on the resources. Like this, we have the computer A, computer B. This computer A, computer B can have access to all the systems, to the database in this of the system, and they can use it to have access to external data. And then you can also have access to data stored in a server or in the outside the premises or even outside the nation, outside the town or city where the data is located. We also have a web distributed spatial data server, in which case the data is accessed over the net. We have a lot of cloud-based storage of data now that the data has stored in the cloud base. So we are going to do some demonstration before we go now so that we can show some of, as we were saying, that a vector data layer data set is like this. A line is implemented in the vector environment as series of arcs and nodes. You can see the nodes that are represented in green, while the arcs that connect them are represented as red line. And this thing can be seen in this format. Then we have the raster environment, and you have a point data. This is the example of a point data, and that point is a non-dimensional data set, and you can see them as a point. And then you have area also as what we have, the reserve. We have the data layer, and then you can actually see if you have the if it is in edit layer, you can also edit it, and we see what we have there. So what we are looking at that the raster data is like this, and we can zoom. When you zoom the raster layer, the level, you can see the pixel, you can see what we have here. We have the pixel, which are in form of polygon.